Beneath the fiery red sunset over the Kharkiv plains, where sprawling wheat fields mingle with the acrid smell of gunpowder, a relentless battle unfolds. In northeastern Ukraine, near a small village along the Kupyansk axis, an elite Ukrainian military unit, an independent drone regiment, prepares for a pivotal mission: to destroy the North Korean-made Type 75 multiple rocket launcher system, a dangerous weapon recently deployed by Russia on the battlefield. 3 days earlier, the independent drone regiment received critical intelligence. A Type 75 multiple rocket launcher newly supplied to Russia by North Korea was spotted in a dense forest near the village along the Kupyansk axis. The Type 75, a copy of China's Type 63, is a mobile rocket artillery system weighing approximately 1,320 pounds, equipped with 12 107mm rockets, each weighing 41.4 pounds, capable of fragmenting into over 1,200 shards or 1,600 steel ball bearings, with a kill radius of 39 to 59 feet. Its maximum range reaches 5.3 miles, with a reload time of about 3 minutes and a full salvo lasting 7 to 9 seconds. Typically mounted on trucks or VTT-32/M1992 armored vehicles, it's highly mobile but vulnerable if not carefully camouflaged. Intelligence came from a sophisticated network, including reconnaissance satellites, high-altitude drones, and ground scout reports. Satellite imagery, captured early 2 days prior, revealed a small forested area where Russian vehicles showed unusual movement. Camouflage signs like green netting and branches were detected but failed to fully conceal a truck carrying the Type 75 launcher. Intelligence analysts deemed it a high-value target, not only for its firepower, but also as evidence of deepening military ties between Russia and North Korea. Commanders were concerned about the Type 75 being protected by mobile air defense units. Russia often deploys short-range systems like the Tor M1 with a 7.5-mile range and missile speed of 1,900 miles per hour, or the Pantsir S1, capable of intercepting targets at 9.3 miles altitude and 2,900 miles per hour, near critical assets. These systems create a dense air defense net, capable of detecting and destroying drones at long range. Ground reconnaissance also reported a Russian infantry unit of about 10 soldiers, alongside a potential Quant 1M electronic jamming system in the area. At a temporary command post, 12.4 miles from the target, technicians and drone operators worked tirelessly in a camouflage tent surrounded by trees to avoid detection. They deployed small reconnaissance drones, capable of flying at 6,562 feet with a 2-hour endurance and high-resolution infrared cameras to verify the target's location. Imagery from the forest, received at 4 a.m. the previous day, showed the Type 75 launcher covered by green netting, but its 107mm rockets, each about 2.6 feet long, betrayed its position. This vulnerability offered a golden opportunity for a precision strike, as the rockets could trigger a chain explosion if hit. The attack plan was devised in a small room, with computer screens casting light on the tense faces of commanders. A senior officer, standing before a digitized map of the terrain, analyzed every detail. Low hills, dry ditches, and dirt roads leading into the forest. "We'll use a decoy and strike tactic," he declared firmly. 2 decoy drones will distract air defenses, while an FPV drone with a warhead hits the Type 75. Timing is critical. We must finish before the enemy can react. The decoy drones, homemade units weighing about 4.4 pounds, were equipped with signal jammers and spoofing devices, mimicking a group of attacking drones. With a top speed of 50 miles per hour and a 3.1-mile range, they were programmed to fly zigzag patterns to draw radar attention. The primary FPV drone, carrying a 3.3-pound high-explosive warhead, had a top speed of 75 miles per hour and a 6.2-mile range, controlled via virtual reality goggles by a skilled operator. Its warhead was designed to detonate the 107mm rockets, triggering a chain explosion to destroy the entire launcher. To ensure success, technicians meticulously inspected every piece of equipment. GPS systems were calibrated for accuracy in adverse weather, with forecasts indicating light northeast winds. Drone batteries were fully charged for a 15-minute flight, sufficient for the 5-mile round trip to the target for reconnaissance drones. Control signals were encrypted with AES-256 algorithms to resist Russian electronic interference. A ground reconnaissance team, concealed in bushes 3.1 miles from the target, equipped with encrypted radios and infrared binoculars, provided real-time updates. They reported a Pantsir S-1 air defense system 1.2 miles from the Type 75, alongside a 10-man Russian unit, with 4 to 5 soldiers directly operating the launcher. The attack was scheduled for sunset, around 7 p.m., when dim light reduced Russian visual detection while enhancing the drone's infrared cameras. Drone operators focused intensely, reviewing each step of the plan. A maintenance team checked every bolt on the drone launch platforms to prevent technical failures. Intelligence analysts continuously updated satellite and ground data, guarding against last-minute Russian repositioning of the Type 75 or air defense reinforcements. An intelligence officer reported that a nearby ammunition depot, possibly containing spare 107mm rockets, was destroyed on April 22nd, limiting Russia's ability to reload the Type 75. Everything was ready as the sun dipped below the horizon. As the sun set, Kharkiv's sky turned deep purple, with low clouds drifting slowly. At a launch site 5 miles from the target, technicians activated 3 drones from a camouflaged base under tree cover. 2 decoy drones took off first, emitting a soft whine as their electric motor started. Flying at 164 feet with erratic zigzag paths, they drew Russian radar attention. The first decoy flew northeast, 1.9 miles from the target at 37 miles per hour, emitting fake signals at 5.8 gigahertz to mimic an attacking drone swarm. The second decoy flew northwest, forming a triangular pattern around the target to further disperse air defenses. Both were designed to self-destruct if shot down, with small explosive charges ensuring no traceable debris. Meanwhile, the main drone operator, wearing VR goggles, sat in a camouflaged mobile control station inside an old truck covered with netting and branches. The screen displayed live footage from the FPV drone's high-resolution camera, with a 120-degree view and infrared capability for low light. The FPV drone launched from a simple platform, streaking into the sky at 62 miles per hour. It flew at 98 feet, using low hills, tree clusters, and dry ditches to evade radar. Its path was calculated to pass through a small valley where Russian radar signals were weakest, based on prior reconnaissance. Ground scouts reported the target area was quiet, with only a few Russian soldiers moving near the launcher, possibly inspecting equipment. Russian air defenses reacted just 30 seconds after the first decoy drone launched. A Pantsir S-1 radar, 1.2 miles from the target, detected the fake signal from the first decoy. Armed with 12 surface-to-air missiles with a 12.4-mile range and 2,900 miles speed, it fired a missile. The explosion lit up the sky as the missile struck the first decoy, creating a small fireball 1.9 miles from the target. This distracted Russian air defenses, focusing them northeast, while the second decoy continued flying, changing direction at 43 miles per hour to prolong interference. It zigzagged, dipping to 131 feet and climbing to 197 feet, emitting fake signals at 2.4 gigahertz to further confuse radar. A critical 30-second window opened. The FPV drone exploited this, quietly approaching from the southwest, where the air defense net was thinnest. The operator received continuous updates from ground scouts, confirming no enemy drones or helicopters patrolled the area. However, a new threat emerged: a Russian electronic jamming system, possibly Quant 1M, activated, causing the FPV drone's control signal to flicker at 3,280 feet from the target. The video feed showed slight distortion, with horizontal lines indicating strong interference. The operator, with hundreds of hours of flight experience, remained calm amid the jamming. He switched to manual control, relying solely on the drone's visual feed. The screen clearly showed the dense forest, with treetops swaying lightly in the wind. At 2,625 feet, the Type 75 launcher appeared under infrared. Its 12 107mm rockets, each about 2.6 feet long, arranged in 2 rows under green netting. The UAZ truck carrying the launcher sat on a dirt road, with 4 to 5 Russian soldiers nearby, one holding an electronic device, possibly a reload control panel. 2 others, armed with AK-12 rifles, patrolled the area, while 2 rested on a nearby log pile. At 1,640 feet, the operator slowed the FPV drone to 50 miles per hour for precision. He adjusted its trajectory, guiding it through a row of tall trees to avoid detection by a Tor M1 system, spotted by ground scouts 0.9 miles away. The Tor M1, capable of intercepting targets at 3.7 miles altitude and 1,565 miles per hour, posed a major threat, but the FPV drone's low altitude and speed made it hard to detect. The operator kept it at 98 feet, using darkness and rugged terrain for cover. The drone glided over a dry ditch, where low bushes provided a natural screen against Russian optical sensors. At 984 feet, the electronic jamming intensified, shaking the screen's image. The operator switched to a backup frequency, restoring control within 3 seconds. He adjusted the FPV drone's attack angle to 45 degrees, targeting the center of the Type 75 launcher, where the rockets were neatly aligned. The 3.3-pound warhead was designed to detonate the rockets, triggering a chain explosion. The drone's infrared camera showed clear details. The netting, slightly shifted by the wind, exposed part of the launcher and the gleaming rockets. At 656 feet, the operator activated target lock. The camera zoomed in, showing the 107mm rockets neatly arranged, their metal casings reflecting infrared light. A Russian soldier seemed to sense something, looking up and pointing southwest. He shouted, prompting two others to stand, but it was too late. The FPV drone dove at 62 miles per hour, clearing a final tree cluster at 328 feet. The operator made a slight trajectory tweak, ensuring the warhead aimed directly at the rocket row. At 164 feet, the Type 75 launcher was fully exposed, with no Russian defenses in place. The netting, though taut, failed to fully conceal the rockets, making them an ideal target. In the final moment, the operator pressed the trigger. The FPV drone slammed into the launcher, its warhead detonating on impact with the 107mm rockets. A massive explosion erupted, lighting up the night sky. The rockets ignited in a chain reaction, creating a giant fireball with thousands of fragments scattering across the forest. The UAZ truck was obliterated, shredded in the flames, with metal debris sparking secondary explosions. The blast, with a 59-foot kill radius, consumed everything nearby. Russian soldiers scattered, but none escaped the explosion's force. From the control station, the team cheered as the screen went black, signaling the FPV drone's mission completion. A second reconnaissance drone, deployed post-strike, flew over at 328 feet to assess damage. Infrared imagery showed the Type 75 reduced to a smoldering pile of wreckage with thick smoke rising. The UAZ truck was torn apart, debris scattered within a 164-foot radius. Nearby trees were scorched, and the ground was littered with craters from rocket fragments. No military activity remained, except for a few surviving Russian soldiers retreating eastward in panic. The strike not only destroyed a Type 75, but sent a powerful message. Ukraine's drone technology has reached new heights in modern warfare. The coordinated use of decoy and attack drones demonstrated tactical sophistication, penetrating Russia's dense air defenses, including systems like Pantsir S-1 and Tor M1. The operation exposed the Type 75's weakness. Despite its mobility and rapid 7 to 9 second salvo, its exposed rocket design made it an easy target for precision strikes. On the broader battlefield, the destruction of the Type 75 weakened Russia's artillery firepower, which relies heavily on overwhelming volume. North Korea's supply of Type 75 systems to Russia, confirmed by intelligence, raised concerns about expanding military cooperation. However, the system's failure here showed that even foreign-supplied weapons couldn't shift the tide against Ukraine's innovative tactics. The April destruction of a nearby 107mm rocket depot further limited Russia's ability to redeploy Type 75 systems. At the base, officers reviewed the strike footage, analyzing each frame for future missions. "This is just the beginning," one officer said, his voice steady with resolve. "We'll keep hunting and neutralizing threats on the battlefield." In the eyes of the young soldiers, from technicians to drone operators, shone pride and unwavering determination. They knew each small victory brought them closer to defending their homeland. As night fell, the forest near the village lay silent, save for the crackling of fires from the Type 75's wreckage. In the distance, other drones patrolled the sky, their infrared cameras glowing like fireflies in the dark. The war was far from over, but with each success like this, Ukraine edged closer to victory.